I wanted to give a solution to one of the problems on the homework and out of the book. And we had the position was t over 1 plus t squared, and we wanted to get the velocity and the acceleration, and then the interesting part, the most interesting part, is when is it speeding up and when is it slowing down. Part of what I want to get at, though, is a thing about the quotient rule. That's a universal thing about taking second derivatives with the quotient rule. If we use the quotient rule first on t over 1 plus t squared, derivative of t is 1 plus t squared left alone, minus, that's really important, t left alone, and then derivative of 1 plus t squared is just 2t. And then over the bottom squared. Now, first observation, I cannot think of a case where, in using the quotient rule, where you expand out the bottom. You just should always leave it as this quantity squared. It's just not useful. Maybe somebody can leave a comment and say, oh, here's where you do that. But I just can't think of a case without thinking really hard, maybe. So that's going to simplify to, that's 1 plus t squared minus 2t squared. So that simplifies kind of nicely to 1 minus t squared over 1 plus t squared squared. So there's the velocity. And that's going to be useful. We're going to graph that using the computer in a minute. Now, the acceleration. That is dv dt. Or in other words, it's the second derivative of position with respect to time. Okay. So that's going to be the derivative of this guy. So we're going to use the quotient rule again, and we want to be real careful, because when you're doing a second derivative with a quotient rule, there's always a simplification that you want to take advantage of. Derivative of the top is minus 2t times, you're going to get 2 times the bottom, oh sorry, times just the bottom left alone. Haha, just kidding. Getting ahead of myself. So that's just the derivative of the top times the bottom left alone. Minus. Now we're going to leave the top alone. And now here we're going to take the derivative of the bottom. So times 2 times 1 plus t squared. That's just, since it's something squared, and it will always be something squared if you're coming out of a first derivative and getting the second derivative now, times the derivative of what's inside, which is a 2t. So times 2t. Oops, that's a 2t. Okay, so it is a bit of a subtlety here, but it's really, practice is the thing, and familiarity is the thing. Do you want to expand this out and then try to recollect? That's often what you have to do when you have stuff added and subtracted in polynomials. But you always want to look for factors, common factors. If there is a common factor, you take that out first, always, and then expand and recollect what's inside. Especially here, because there's a factor of 1 plus t squared on the top. And now, what did I do wrong here? Kind of in a rush, I guess. This was 1 plus t squared squared. Now it's that squared again, so it's the 4th power. Okay, now it's correct. So, congratulations to anyone who saw that error already. So, 1 plus t squared on the top, that's a common factor, and that's going to cancel out on the bottom. Let's do it carefully, because people tend to get into the error of doing partial cancellations when we do this not carefully. I'm going to just factor out the 1 plus t squared. So that's going to leave a minus 2t times one other factor, 1 plus t squared. And then minus 1 minus t squared times 4t. And then over the bottom, unchanged. And now I can cancel out that one with one of these guys. And so that's just going to be, that goes away. And that changes to a 3, down to 33. Okay, now there's nothing better to do on the top. I don't need really these brackets anymore. Nothing better to do on the top than to expand and recollect. And so we get minus 2t minus 2t cubed. Actually, there is something to do on the top. Never mind. Often there isn't much better to do. But you know what? I could have factored out a 2t as well. I was trying to focus on the 1 plus t squared. But here it's actually kind of nice. Let's focus on let's take the 2t out. So we get minus 1 minus t squared, and then that's a 2, so minus 2 times the quantity 1 minus t squared. Let's hope I'm doing this correctly, or else I'll just show the world my algebra errors. Okay, so now that's going to be 2t times, we're getting a plus 2t squared minus t squared, so that's a t squared. And then we're getting a minus 1 and a minus 2, so minus 3. Yay, and that's the right answer. Over 1 plus t squared cubed. So there's a certain amount of work, but it's not nearly as much work as if we hadn't observed this big thing right at the start of being able to cancel out the 1 factor 1 plus t squared. This was only a cubic, and in fact it was a cubic that even had another visible factor, and then the bottom is just 1 plus t squared cubed. So there's my acceleration. So now I want to plot position, velocity, and acceleration together, and I've already done that in a different window. So here's position from 0 to 4, which is where we're interested in it for this problem. Here's velocity. Notice that the position starts out coming up with a good derivative, a slope, and that's why this is high to start with. When the position maxes out, that's when the velocity hits a 0 and then becomes negative for the rest of time because this guy's sloping down for the rest of time. And then the acceleration, let's see, if you take this velocity curve and look at its slopes, 0, negative until right about here, and then slope small positive. Okay, that's why this is 0, negative, pretty small negative, because this is steeply sloping down. And then coming up, hitting 0, and then just a little bit positive as the velocity is going upward after. Now, here's the conceptual part of the problem, as opposed to the calculational parts I've been emphasizing so far. Where is the particle speeding up or slowing down? You can't answer that just by looking at A alone or just looking at V alone. It's very tempting to say, oh, speeding up, that should be where A is positive. That's going to be after this point here. Or slowing down, that's going to be where it's negative. That's not true. We talked about in class and on the other video how it's when V and A are in the same direction. So we've got to keep track of the signs. Okay, V is positive and A is negative until one of them hits a sign change. That's at 1. So from 0 to 1, the particle's going to the right but being pulled to the left. And so it's slowing down. You can actually read that directly off the x-graph. It started with a steep slope and then it's going towards 0. In this region, that's slowing down. So to get a vague idea of the answer to speed up, slow down, you actually can just look at the x-curve. To get it precisely, that's where we need V and A. So it's going steep, not so steep. That's slowing down. Then it's going from a 0 velocity. It's turned around and turned the other direction. And then for a little while, it's getting steeper. But then somewhere in here, it's getting less steep again. Well, where is that? Now, that's where the V and A are really useful. Look at the next sign change. From 1 to somewhere around 1.7 or 1.75 or something, and we'll see what that is exactly in a minute, you've got V and A in the same direction. They're both left. They're both leftward. V is negative, so it's going to the left, and A is negative, so it's being pulled to the left. That means it's going to speed up. But then they go back to being opposite sign after about 1.7 whatever. So what is that number? Well, what was really, the 1 was pretty clear for the start of that interval of speed up, and that's where this is equal to 0. Remember, when you take a fraction and set it equal to 0, you just have to look at the top. That's where t squared equals 1. Okay, so that's going to be t equals 1. And then here, where is this equal to 0? Well, it's equal to 0 at t equals 0, which is right at the start of where we care about, and then also where t squared equals 3. Aha, okay. So if we set that equal to 0, that's going to be where t equals root 3. Oops. Okay, and so that's the exact value of that number we had there. So in between 1 and root 3 is where it's speeding up. Everywhere else, it's slowing down.